This is going to be a fairly complex presentation, but you'll be thankful it's the last one of today. What I'm going to try and do is explain climate change, but not the conventional approach. It's an approach that we believe is a true reflection of what's happening on the planet. And it's also an approach that gives us the possibility of having a solution, which is certainly not the situation at the moment, because there is no possibility that we can persuade the countries of the world to reduce CO2 production from the burning of fossil fuels quickly enough to prevent a 3°C rise in temperature. And that's the critical temperature. At 3°C rise, then there's going to be serious climate change. Indeed, it's no longer called climate change, it's called a climate emergency. And I think the recent events in Australia really bring it home to us what is going to happen in the future unless we can reverse this process. And currently we're only at 1.5°C of temperature change. So, to begin with, I want you all to take 2 deep breaths. Okay? One of those breaths came from the oceans. Indeed, more than 70% of our oxygen comes from the oceans, from plants living in the oceans. Very small plants, such as the radiolarian. They only measure about 10 to 20 microns in size, but 70% of all the oxygen that we breathe comes from plants such as the radiolarian. It's quite an unusual phytoplankton. Radiolarian is based on strontium, so it's one of the few metal life forms on the planet. It's not based on carbon as a skeletal structure, it's based on a metal. Now you're probably thinking, well, how can 70% of our oxygen or 80% of our oxygen come from the oceans? Surely it comes from trees and grass growing on the land. Well, in reality, that is not the situation. Effectively, you could cut down the Amazon rainforest and it will make no difference to the level of oxygen in the atmosphere. It's because the Amazon rainforest and most mature forests are in balance. When a tree grows, it absorbs or uses CO2, carbon dioxide, to build its biomass, and it produces oxygen. But in a mature forest, trees are also dying, and when they die, they decompose. And when they decompose, they put out CO2, and they consume oxygen. They're in balance. So the net result of mature forests and grasslands is zero. Now, I'm not saying that we should cut down the Amazon rainforest. That would be ridiculous, because it's important for other aspects of the environment. But in effect, the net input of plants on land do not remove CO2 and they do not produce oxygen, because they're in equilibrium. The only parts of the planetary ecosystem that produces oxygen is the ocean, small plants in the ocean, because when they grow, they're producing oxygen, they're absorbing CO2, and when they die, they fall into the abyss. So they go down 4,000 metres or up to 11,000 metres in the Mariana Trench, and then the carbon does not decompose. It stays there, and this is where oil and gas comes from. The only other part of the ecosystem where oxygen is produced and CO2 is fixed are wetlands, marshlands, peat bogs, mangrove swamps. It's part of the terrestrial ecosystem whereby when the plant dies, it falls into water with no oxygen. And under those conditions, it doesn't decompose, so the carbon is locked out of the system. And that's where coal comes from the compression of trees. So, Man is producing CO2 from the burning of fossil fuels, and nature is removing that CO2 by building up algae cell biomass and depositing on the oceans, or ocean floors, and in wetlands. But man is producing much more CO2 than the ecosystem can actually metabolize and remove. It's displaced the balance. Now, to put numbers onto this, the burning of fossil fuels, coal, oil, gas, is putting 35 gigatons of CO2 into the atmosphere every year. 1 gigaton is 1,000 million tons of CO2. Now, if you're to compress 1 gigaton of CO2 into a cube, it would measure 1 kilometre square. So it's a huge amount of CO2. We're also producing 5 gigatons of CO2 from the burning of trees. Now, the situation in Australia is tragic at the moment, and that's contributed a huge amount of CO2 into the atmosphere, but currently we're burning trees to create space for new farms. And this is a major input to the CO2 in the atmosphere. Now, the part of the ecosystem where we remove the CO2 are the oceans and the plankton in the oceans, and they take out in order of 12 gigatons of CO2 every year. The wetlands on the terrestrial side are taking out in order of 5 gigatons of CO2, and then there are mineral reactions, which are taking out 5 to 6 gigatons of CO2. So the difference between what we are producing and what we're taking out by nature is 17 gigatons. That's what's causing climate change. That's what's elevating the temperature of the planet. And that's why we're in trouble. Now, all that CO2 is building up in the atmosphere, but a high percentage of it is also dissolving into the oceans, into the water. And when you add CO2 to water, it forms carbonic acid. So the oceans are becoming more acidic. Now, ocean acidification is often called the evil twin of climate change. I think it'd be more appropriate to call it the evil big brother, because I really think ocean acidification is actually much more important than climate change. And I'll attempt to explain that. If we go back about 80 years, oceanic pH was about 8.2. From the 1940s, though, it started to drop very rapidly. And currently, oceanic pH is about 8.04 to 8.06. If you then project that forward for the next 25 to 30 years, we're going to drop down to pH of 7.95. At that pH, carbonate-based life forms in the oceans will start to dissolve. They cannot survive this. And what that means is that the root of the food chain, the powerhouse of the planet, is going to die. And with that, we will lose the food that feeds all the whales, all the seals, all the birds in the oceans, and all the fish. So potentially in 25 to 30 years' time from now, we could be looking at losing the entire marine ecosystem. And it will happen quick. There will be a cascade or trophic cascade destabilization of the entire system. And with the loss of all those fish, we lose the food supply for 1 billion people. Climate change is the least of our problems in comparison to ocean acidification. And this is happening now. It's not guesswork. We know the rate of change of pH. We know when it gets to 7.9, then there's going to be this trigger. And everything will appear perfectly fine up to the point we reach the tipping point. Then over a course of perhaps 2 or maybe 3 years, the whole system will collapse and the fish are gone. That would be absolutely tragic, but we are actually on that path. Because pocolithophores, these are marine phytoplankton, they are responsible for 25% of our oxygen. They cannot survive. To put it into perspective, these small plants are responsible for building land. The white cliffs in England are made from pocolithophores. It's algae. It's algae that's been compressed over millennia. And that's one of the principal mechanisms by which we remove CO2 from the atmosphere and lock it out of the ecosystem. But we're going to lose that mechanism unless we can reverse what's happening in the oceans. So really, that is not good news for the planet. And it gets worse. You probably think, how the heck can that get any worse? But it is, because the oxygen levels are also dropping, and that is never discussed in any climate change reports. And it's dropping 4 times quicker than the CO2 is going up. When you burn fossil fuels and produce CO2, then you also consume oxygen, but the oxygen levels are dropping faster than can be explained by the burning of the fossil fuels. So what we're looking at here is ecosystem destruction. And when we look at oceanic productivity, and go back 60, 70 years, oceanic productivity has dropped by 50%. And the animal and plant life in the oceans represent 90% of all life on the planet. So we're in a situation now where life in the oceans and life on the planet is dropping at a rate of almost 1% year on year. This is absolutely not sustainable. And this is published information. It's in the public domain. It's not something I've made up. It's satellite imagery from NASA has confirmed this, and many other studies and reports around the world have confirmed this. And it's been since the 1940s and 1950s. Going back to the balance again, the CO2 production. So we have an imbalance of 17 gigatons of CO2. And as I explained, this is why we have climate change. And the oceans are taking out 12 gigatons of CO2, but we have lost 50% of the productivity of the oceans. What if we hadn't lost that productivity? What if the oceans were healthy as they were back in the 1930s, 1940s? It wouldn't be 12 gigatons that was being removed, it would be 24 gigatons. Then we wouldn't have climate change. It would be in balance, assuming, of course, we stopped burning trees and we started to restore the wetlands. But we're destroying the wetlands and we're burning more and more trees every year. But it is technically possible to bring the planet back into balance if we can restore the oceans. You know, the oceans are amazing. I'm a marine biologist, and within Dryden Aqua, we actually have 4 marine biologists. So it's a subject really very close to my heart. But the question is, why? Why have we lost 50% of oceanic productivity? Why have we lost the plankton in the 1950s? Certainly not climate change, because a slight increase in temperature and an increase in CO2, CO2 is plant food. There's also nutrients, ammonium and phosphates going in from human sources, so we should be seeing an explosion of life. But we're seeing the reverse. Our explanation is pollution. Pollution is the reason why we're seeing this reduction in productivity in the oceans. But you know, the policy up until relatively recently is that the solution to pollution is dilution. Dump it into the rivers, dump it into the oceans. They'll dilute, it's not a problem. But it is a problem. Because the chemicals that we have been producing since the 1940s and 1950s are not natural chemicals. They are toxic forever chemicals. They do not break down an ecosystem. They keep killing and killing and killing. We should not be putting these things into the environment. They are too dangerous. And that started in the 1940s, when we started to see DDT and PCBs. Toxic forever chemicals will keep destroying the ecosystem. And we have to stop discharging them. But there's a huge amount of pollution being discharged into the seas every year, billions of tons into the rivers, from all different sources, from Alaska to the Caribbean. Huge amounts of rubbish. We also have atmospheric pollution, and anything that goes into the atmosphere eventually ends up back in the rivers and back in the sea again. So we have the exhaust from car fumes, we have industrial pollution, but one of the biggest polluters, which is never discussed, are car tires. Car tires are responsible for about 30% of the microplastics going into the atmosphere. And every square metre of the planet receives 500 particles of plastic every day, everywhere. From Europe to Alaska to the North and the South Pole. This plastic is falling out of the atmosphere. We have to be a bit more intelligent about what we're doing. Second to the petrochemical industry is the textile industry in terms of pollution. They also use about 10% of the carbon budget of the planet. So we really have to address the textile industry. And this is why driving Aqua went into Bangladesh, into Dhaka, to try and sustainably treat textile wastewater. Because we felt that we could provide a solution that could eliminate this problem. And that project cost us money. But we did have a solution for it, which is a sustainable solution. It wasn't a zero discharge system, but it was effectively a zero impact system. We were not destroying the environment. We're actually improving the quality of the water into which we're discharging with that textile plant in Bangladesh. Now all this pollution, all this waste ends up in the oceans. And with regards to plastic, we have 2 rotating gyres in the Pacific. Each one is about the size of France. We also have it in the Indian Ocean. We have it in the Atlantic. And this plastic kills in the order of 1 million seabirds every year and over 100,000 whales. I actually think these numbers are way underestimated. I think it's a great deal more than that. And it's tragic. We shouldn't be doing this. We shouldn't be using the oceans as a dumping ground for all our waste. We should be recycling and reusing. But in reality, it's probably the plastic and the components that we don't see that are actually really dangerous. You can hardly imagine it could get any worse. But it can. The coral reefs around the world. We have killed 50% of the world's coral reefs, and they're not coming back. Coral reefs are the breeding ground for 25% of all life in the oceans. And they will be dead within 10 years, unless we can do something about it. But governments and scientists are all reporting this is climate change. In reality, it probably isn't climate change. It's chemical pollution. And one of the biggest killers for coral, the coral are an animal, but they're a symbiotic animal. They actually have an algae that lives inside them. And when you discharge a chemical such as oxybenzone, which is the active ingredient in sunblock, this chemical gets absorbed onto microparticles of plastic. The coral then grabs it, pulls it inside. Now, the oxybenzone is not actually toxic, but what it then does is it reacts with sunlight and it produces free radicals. That really stresses the coral. It then dumps its algae. This is called coral bleaching. And then the coral then becomes really sensitive to elevated temperature. And if you have an increase up to 32 degrees centigrade, then the coral will die. It's because it's been sensitized, it's become much more delicate because it's lost its symbiotic partner. Back to oxybenzone, this active ingredient in sunblock, it's toxic at a level of 62 parts per trillion. Now that's an incredibly small number and kind of difficult to comprehend, but the world produces 20,000 tonnes of oxybenzone that goes into sunblock every year. And if you were to dissolve 20,000 tonnes of oxybenzone into the world's oceans at the one time, you would kill all life in the oceans because it is so incredibly toxic. And we put this into cosmetics. Now, we've produced a video which I think gives a pretty good explanation of what's going on. So I will now hopefully play a video. Sadly, I fear we may be too late to save the corals, but there's a great deal of research underway at the moment with reseeding coral reefs, so hopefully we can preserve them. So this chemical is in 3,500 different cosmetic products. And part of the reason why oxybenzone is so toxic is because it is lipid-soluble, hydrophobic. And many of the most toxic chemicals that we discharge have the same characteristics. They are lipid-soluble and hydrophobic. So if we address this one, then we address most of the really toxic chemicals that we're discharging. We now have a situation that 1 in 15 of every living organism in the oceans, down to bacteria, contain plastic. The plastic is also hydrophobic and will attract hydrophobic chemicals. So part of the reason why these chemicals are so toxic is because they are not in the water. They get absorbed onto the plastic, and the plastic is behaving like a sponge. And it will concentrate these chemicals by many thousands of times. So the plastic is acting as is inoculating the animals and the algae. So they get a large dose of these chemicals right into their bodies. And when the nanoparticles get below 20 nanometers in size, they'll pass straight through the tissue of the plankton. So they don't just have to eat it to get infected, they just have to be there and it will pass through their tissue. And I think this is why we're seeing a disruption of the ecosystem, the marine ecosystem. It's not just the chemicals on their own, it's a combination of these hydrophobic chemicals in combination with plastic. So it's a two-pronged approach. And we know this is happening. There's a recent study in the Mariana Trench, or Challenger Deep. The Challenger was an expedition back in the 1800s from Edinburgh. And they were the first to map the Mariana Trench. It's the deepest part of the ocean. Typically the abyss sits at 4,000 metres in depth, but the Mariana Trench was down to 11,000 metres. And they've taken grab samples of the sediment from the bottom of the Mariana Trench, and the level of pollution in that sediment is 50 times higher than some of the most polluted rivers in China. And this is the most remote part of the planet. So what's happening is that the plastic is absorbing the chemicals, the phytoplankton, the zooplankton are eating the plastic, or it's being absorbed into them, then they're dying, then they're falling into the abyss. And this is why the levels are so high through the whole abyss and in the Mariana Trench. And to have levels 50 times higher than the most polluted rivers, it's not right. Now, by this stage, you probably want to jump off a cliff, but there is hope. Or at least I hope there's hope. Because I think we can still prevent climate change, but it's not by trying to reduce CO2 emissions. Now, I'm all for planting as many trees as possible, because when those trees are growing, they will be absorbing CO2. We just can't cut them down and burn them. But there is no possibility that the world will come together and reduce their CO2 emissions in time to prevent a 3 C rise in temperature. It simply isn't going to happen. We're still accelerating in terms of the amount of CO2 that we're producing, and will be for the next 10, if not 20 years. But what if we can restore the marine ecosystem, improve productivity, create a carbon sink, and then we can remove the CO2? Then we can stop it and possibly reverse it. Because if we can eliminate pollution of the most toxic type, then marine productivity will come back, and it will come back really quick. Because trees take, 100 years or more to grow. But coccolithophores, carbonate-based phytoplankton, they only take a few hours, maybe a few days. Phytoplankton, or marine bacteria, perhaps a few minutes. These organisms are growing 1,000 times or 1,000,000 times quicker than a tree or grass. So if we can restore the productivity, remove the brakes on the ecosystem, and allow these bacteria and phytoplankton to start removing the CO2, then the ecosystem could recover really quick. If we don't do it, then we're looking at a cascade collapse happening within a period of 2 or 3 years. But equally, if we can remove all these chemicals from the environment, then it can recover equally as quick. And if we can do that, bring marine productivity back up to what it was before the 1940s, stop burning trees, restore our wetlands, then we bring the planet back into equilibrium. And if we reduce the burning of fossil fuels using alternative energies, then we can start to reverse the process. But we need to take action now, because in 10 years it will be too late because of the inertia that's built up in the system. We have to start now. And if we start now, and within 10 years have eliminated the majority of the really toxic chemicals from our environment, then we can do this. And everyone here can play a role in doing this. And it could be quite simple. First of all, buy organic. Only use organic products if at all possible, because then you're not consuming or using herbicides and pesticides or antibiotics, don't wear plastic clothes, especially a fleece. Washing of plastic clothes is responsible for the vast majority of plastic going into the environment. And we can stop this. It's easy to stop it. And those two factors together can contribute 10% towards preventing climate change. Don't use toxic chemicals in your home, and certainly don't use toxic chemicals as cosmetics, because not only are they toxic to the marine ecosystem, they're also toxic to people. So it makes sense not to use these products. Of course, we have to become carbon neutral, but you'll see I've allocated 15% of the solution to this problem to the reduction of fossil fuels. Because if we don't fix the marine ecosystem, then it makes no difference what we do with CO2. It's still important, we have to do it, but it's not critical. Stop atmospheric pollution from the burning of toxic chemicals and the discharge of particles into the atmosphere, in particular the plastic and the rubber that comes from tyres. But in the UK now, in parts of Europe, and I know in parts of India, they're actually discharging or disposing of plastic into roads. I think it's a clever idea to get rid of the plastic, but as the roads wear down with the traffic, this is releasing the microplastic back into the environment. An incredibly stupid thing to do. So if anyone has an opportunity to apply influence, then persuade governments not to use roads as a dumping ground for plastic. And we need to lobby governments and the water industry to put tertiary treatment into the back end of wastewater plants. Because most wastewater plants are biological. They were designed in the 1920s. They are not designed to remove man-made chemicals. And most of the chemicals that go down through the drainage system into the sewers and into the water treatment plants is not removed by water treatment plants. But with the appropriate technology, tertiary treatment on the back end of these treatment plants, we can make a huge difference to the environment by reducing pollution. And I think everyone here would be in favour of eliminating pollution in our rivers and our lakes. We saw an extreme example in Bangalore with the burning lakes. This is ridiculous. We have to stop polluting our environment. We have to make the planet sustainable. And if we continue to discharge chemicals and waste into the environment, then it will not be sustainable. But by far the biggest impact that we can have is green chemistry. It doesn't have to cost money. Applying green chemistry could actually be a huge boost to the chemical industry. But we can't keep making chemicals that are toxic forever. If they're toxic forever, then we will kill the environment, we'll kill the oceans, and if we lose the oceans, then the terrestrial ecosystem will collapse. So it's really important that we do this. And if we all do it, and live responsible, sustainable lives, and demand a non-toxic environment, then I truly believe that we can restore the Earth and prevent catastrophic climate change.